Hello, we're going to look today at these two DC to USB-C and A power boards. So here's my portable computer setup that I've been building that connects to a laptop interface. And so this USB-C port is currently used to connect to that laptop interface and provide power to the portable monitor. Now, this can brown out at about 13 watts. And so I want to resolve that so I can run the monitor at higher brightness levels without worrying about it browning out. Also, I'd like to reclaim this USB-C port and use it for other things perhaps. Now, I've designed this case and 3D printed it, and overall it's been pretty good, but I'm going to modify the power supply in here and then potentially wire a couple of these up into the internal wiring of this barrel jack to also pull power and put a couple additional ports over next to this. And so that will provide me as many ports as I'd like of USB-based power in addition to the ports here. One of the things that I found are these USB power converters that convert from standard DC power between 6 to 35 volts and step down to a USB-C connection. Now I have it hooked up to a digital tester as well to watch the output here. You can see here I have it hooked up to this battery. This is a LiFePO 4 battery that I'm using for purposes of testing. I'll plug my phone in here. And as you can see, it's taking that 12 volts in and stepping it down to 9 volts and putting out a half an amp, around 5 watts for my phone. This can only step down, meaning that a 12 volt battery can only go down to 9 or 5. What I'd like to do as well is use this for 20 and 12 volt applications such as my laptop. So let's see how it fares if I increase the amount of voltage going in here via a boost converter. Alright, so here is a pretty large boost converter which can take in the 12 volts and increase the voltage to at least 30 volts, 35, the maximum that the card can take, the circuit can take. Putting out 29 volts. All right, I'm going to go ahead and modify the voltage here by turning the knob on the potentiometer. All right, we've got it now at 34 volts. All right. So we've plugged the 35 volts into this board here, and I'm not getting anything out. All right, dropped it down to 30 volts and the light came on. So definitely 35 volts is too high for this. I believe it says it is 6 to 35 volts, but that looks to be incorrect. Okay, so here is my Surface laptop, and this is able to be powered by the USB port here. And so let's see what happens when I plug the laptop into this power system, and let's see if I can get any power through it. All right. So it looks like we're getting 20 volts at 19 watts here. No problem. All right, let's see if I can cause it to require more power. Oh, and it looks like it just rebooted. Yeah, okay. Probably the power draw is higher than this can handle. Now, this is supposed to be up to 60 watts, but I'm pretty sure it's not. Yep. Boost converter here can definitely take and provide hundreds of watts, at least 300 watts. So that is not the issue here. Let's see what happens if I, say, lower the voltage, for example. Well, it looked like it almost worked. I've dropped the voltage down to 24-ish. And this thing definitely seems like it can pull up to, say, 25 watts without issue. But as soon as you can see I turned on the computer, it pulled more than 28, goes up to 50 briefly, and then just dies out. So definitely not, I would say this is probably rated at best 30 watts if you're lucky. Well, it looks like it's been able to stay on here. Let's see if I can. Yeah, it's just going to reboot. So I think 30 watts is kind of the maximum here for this device. Now, interestingly, I have another one of these, similar design. This one takes a barrel jack in, and this one's supposed to be only rated to 45 watts. It's a different design. It's not Quick Charge 4.0. I think it's only Quick Charge 3.0. Let's see how this fares. Maybe it'll be better. All right, let's see how this one works out. Wow, okay. Well, this one seems to be doing much better. It's gone up to 30 watts without issue. Let's see if it can go even higher. All right, so this circuit is easily handling 37 watts. At 20 volts. Whereas the other one could not even get that far. Nice. So what's interesting about this is it looks like it actually is limiting the current draw more effectively because this is staying at 37.4 and not increasing beyond it. So I think the other one was getting cut off. It was trying to pull too much and didn't have a circuit to hold back the current and limit the current, and it would just shut down. Okay, well, thanks for watching. I hope you found that interesting and useful. If you're interested in converting DC power into USB-C power, this is probably really helpful.